Hello, my name is Tony Petrosian. I work at AWS and I'm the general manager for Amazon Aurora. Today we're going to talk about what's new in Aurora. Our agenda will cover some of the key features of Aurora and then we'll dive into the new stuff. Over the last 12 months, we've been working on a number of features as requested by our customers that we've already released, and some of them we'll be releasing shortly, and more of them will be released over the next few weeks. So with that, let's get started. So Amazon Aurora is our managed database service with compatibility for MySQL and Postgres. The idea here is that if you have an application that was written for MySQL or Postgres, you can basically drop it into Aurora and it will work without having to change code and rewrite the application. And the motivation behind Aurora was to offer the availability and the throughput that demanding applications require without having to go to a commercial database for those functionalities. The simplicity of Aurora is in its cost effectiveness and compatibility, where using a dialect for Postgres or MySQL, which is a common database used by a lot of people, allows you to just build an application without having to learn anything new. And then we have this simple pay-as-you-go pricing model, which makes it really simple to use Aurora without having to worry about any commercial licensing. So that's why we went out and built Aurora for our customers. Now, there are a number of innovations in Aurora that make Aurora kind of unique when compared to your community Postgres and MySQL. So let's start with some of the basics in the database world. In general, databases are layered, where you have at the top of the database is your SQL layer, which deals with query processing and so on. And then you have your transaction layer, which deals with the actual transaction management for the database. And since databases deal with a lot of data, there's always some caching element. And then finally, there's the storage of the data and the logging of the changes. In the bottom layer where you have the storage is where you get your durability. This is where databases, relational databases really shine. They offer you the ability to commit transactions without having to worry that the data will be lost. So in this model, you have a compute layer and a storage layer all mixed into a single engine, a Postgres engine or a MySQL engine that does all the work. As in the application, the database application running on the server deals with the SQL part, the transaction part, caching, and the log and page management, all bundled up into a single engine. And what we did with Aurora is we took this storage and compute and we separated them out. And we separate the layers in the database, where you have your SQL layer and your transaction layer. And this is where you really write your applications to. Your applications are basically sending SQL commands to the database that are either transactions or queries. And having separated these things out allowed us to go and build a storage mechanism for a database, which was specifically built for storing databases in the cloud. This is really important because in order to achieve the availability and the durability that we need for the throughput that we need for Aurora, we really needed to have a storage system which was self-healing and was able to scale independent of the engine. The other benefit is that we pushed all of the work, which usually a database engine does, with relations to managing the cache, managing the pages, managing the logs, log records, recovery, and so on. It all got pushed down to the Aurora storage layer, which does that on behalf of your application. So how does that work? In Aurora storage, we have 6 replicas for every piece of data. And these replicas are scattered across 3 availability zones, with 2 replicas in each availability zone. This is what gives us the durability that we need for a commercial grade database, where even if some node happens to die because of a bad power supply or whatever reason may be, or even if an availability zone is unavailable, the storage system will continue to work and serve the database. So having 6 copies allows us to have 2 copies per availability zone, which also gives us the performance that we need. Because if you just have a couple of replicas of the database, every transactions you have to wait for both nodes to make the changes durable to disk. Where in the case of 6 replicas, we just wait for a quorum of the 6 to come back, and usually the fastest who come back are sufficient, and then we move forward. The data is written in these 10 gigabyte chunks. So when you have a database volume in Aurora, it doesn't matter how big the volume is, maybe it's a terabyte or 10 terabytes or 50 terabytes. That data is segmented in 10 gigabyte chunks. And these 10 gigabyte chunks are what we replicate across the availability zones. And as your database grows, we keep adding more segments of these 10 gigabyte segments. And as segments fail, we replace them. And all of this happens without impacting the performance of your application. So this is the basics of Aurora. Now, what are the benefits of separating storage and compute and pushing down all of the storage processing to the storage layer? Well, this is what the Aurora storage layer does for your database and frees up your database from having to do this work. Whether it's redo log processing, crash recovery, fault tolerance, ability to create database snapshots, backups, ability to restore, making clones or backtracks of the database, all of that is done by the Aurora storage engine. And that allows your database to just focus on the transactional and query processing aspects of it. So the instance that's actually running the MySQL engine or a Postgres engine, which your application code depends on, is now free from having to do all of this other work, which is pushed down to the storage layer. That, in general, allows us to build capabilities for Aurora to have commercial-grade availability and throughput without having to impact compatibility with MySQL or Postgres. So you don't have to rewrite your application to get the benefits of something like cloning a database in just a few seconds. So now, this is the basics of Aurora. And there are a lot of sessions out there that go into detail of Aurora and how it's built. There are sessions on demystifying the Aurora storage layer. So there's plenty of content for you to go and dive deep in any of these areas. Now, with that, let's go look at some of the new features that we've done for Aurora. So, at the storage level, some of the work we've done recently was to release support for 128 terabyte databases. Until recently, you could create a database in Aurora and you would be able to grow to 64 terabytes, and that was the limit. And so this year we raised the limit to 128, and this is, basically our attempt to continue to grow and invest in making Aurora a bigger and faster and higher throughput database. And so we'll continue to increase the limits as time goes on. But today, both in MySQL and Postgres, you can now have databases up to 128 terabytes. Now, we also released dynamic management of space. So in most databases, you allocate some space and your database grows and grows. And when you go and delete data, maybe truncate a table or drop a few tables or delete a lot of rows, that doesn't necessarily mean the database gives up the space because it's already allocated. So you have empty pages that could be reused, but there's still pages that consume space. With Aurora now, the dynamic resizing ensures that any free pages are actually released so that you don't have to pay for it. So you can actually go and create a database, load a bunch of data, and then go truncate a bunch of tables and see that the storage that's being consumed and the storage that you pay for is actually shrinking. Now, the reason we can do this is because Aurora is really fast in allocating space when it needs it. So really don't have to worry about having to deallocate pages, because then it'll be slow to reallocate them. Because again, allocation is really fast and the database can dynamically grow shrink as you need it. So the point of this is, of course, you will save lots of money if you have databases that are frequently reduced in size. For example, you might have a database where you load a bunch of data, you do a bunch of processing. At the end of the month, you truncate all the tables after you're done processing, and then you start the cycle again. For the times where the database is empty, well, you don't have to pay for the storage. This feature is available for, again, MySQL and Postgres, and it's there, and you don't really have to do anything to use it. You can just go and look at your CloudWatch metrics and see what your space consumption is, and you will see the benefits of it. Another feature that we recently released this year was Snapshot exports to S3. Now, why is this an important feature? Well, if you have data in the database, the chances are that data has value, and somebody's going to want to do analysis on it, perhaps run some queries and analytics. So, of course, you could run queries against the database, or you can make copies of the database. But what export to S3 allows you to do is to go and pick a database or some set of tables in the database and export the data into an S3 bucket. And the process is completely serverless, and we manage all of the resources necessary to actually do the extraction of the data from Aurora, converting it to Parquet, and then putting it in an S3 bucket of your choice. And this process runs off of your snapshots. So it actually doesn't disrupt your database at all. So you can continue to use your database for whatever production workloads that you're doing, while this data extraction and conversion process runs off of snapshots on a completely different set of systems. You can use any snapshot for this, or you can create a new snapshot or the latest snapshot. And once the data is in S3 in the form of Parquet, then you could use a tool such as Athena to do query processing, or any other tool that is able to read the Parquet format, which is common analytics format, and lots of tools out there support it. So again, this is another benefit of using Aurora, where you can get the data out of it without impacting your production workload for analytics. Moving on, we recently started supporting Aurora in AWS Backups. Now, AWS Backups is used for managing backups across many services. So if you have an application that uses, say, Aurora, and maybe it uses DynamoDB and some file systems and some virtual machines, and you want to be able to take snapshots or backups of this application, its entirety, where all the components are backed up, you can basically go to AWS Backups and establish a set of policies that are easily created, and then the policies apply to all the services. So now you can basically create snapshots of Aurora databases in AWS Backups. These snapshots that are created in AWS Backup are managed by AWS Backups, so you have this nice ability to separate out the concerns and meet all of your requirements for regulatory or other business compliance needs that you have for backups. Again, there are no additional charges for AWS Backups. You just pay for your Aurora backups like you always do, whether the backups are made by AWS Backup or managed by AWS Backup, or you just make the backups with Aurora at the console or CLI. It's all the same. It's also nice because you can do both. You could go and manage a set of backups for compliance reason using AWS Backups, and you can also use your backups in Aurora for usual reasons people do backups, whether it's recovering from errors or other disaster recovery solutions. So that's basically it for improvements that we've made in Aurora storage recently. Now, moving on to the compute aspects of it. So soon we'll release Aurora support for Graviton 2 powered instances. Of course, Graviton is a AWS custom ARM server that we built. And there are a lot of nice qualities to Graviton, but mainly price performance. You get better performance and you get better price with Graviton 2 instances. This will go into preview soon in the next few weeks. I actually don't know when you'll be watching this video, so who knows. Just trying to stay away from specific dates so that anytime you're watching it, you'll know. But I'm recording this in early December, so this should be out soon. So what is special about Graviton? Our Graviton systems are a single socket with 6 to 4 cores. That means every core has uniform access to memory, so there are no NUMA issues related to Graviton instances. We'll support MySQL and Postgres on Graviton with all of the various sizes that are supported in Graviton. Another nice thing about the Graviton processor is that each core is a physical core. So if you look at a regular R5 instance, each virtual CPU is basically tied to a simultaneous multi-threading, an SMT thread. So when work comes across each vCPU, there's only one execution pipeline for that. On the other hand, with Graviton, every core has its own, every vCPU has its own core. So as work comes in, each gets its own execution engine, and that leads to a better performance when you're running CPU-intensive workloads at high scales. So this is a graph that shows the performance of doing scans, range scans, with 1,000 rows. It's a 3-level nested loop. And you can see as we start pushing the database harder and harder, the blue line is our Graviton R6G16 extra large. The purple line is R516 extra large, and the yellow line is the R524 extra large. And you can see that the Graviton continues to deliver higher throughput as we increase the number of connections to the database. And this is where Graviton starts to shine. And when you look at the difference between an R516 extra large and R6G16 extra large, it's about 1.5x better with Graviton. And the Graviton actually outperforms the R524 extra large in this workload, which again is very CPU intensive. So look out for Graviton and give it a try. By the way, Graviton is also supported in RDS, MySQL, Postgres, so you can go try them out on RDS as well. Now, moving on, we have a lot of customers who use Aurora Serverless. Lots of benefits for Aurora Serverless with respect to scaling and not having to provision servers and not having to manage resources. But we've made a lot of investment in Serverless v2. And one of the biggest thing about Serverless v2 is that in the scaling in Serverless v2, we've moved to fine-grained scaling. And what does that mean? Well, in regular Serverless, you go from 1 ACU to 2, and then 4, and 8, 16, 32, because every time you need more resources, the instance doubles in size. However, in Serverless v2, we've moved to adding just about enough ACUs that your workload demands. So you go from 1 to 2 to 3 and 4 and 5 and so on. And this allows you to get much better price performance from Serverless v2. Now, scaling in Serverless v2 is also instantaneous. That is, as you go from 1 to 2 to 4 or 5, 6 ACUs, it's an in-place increase of resources that are afforded to that database. So you can scale in place and instantly. And your workloads don't have to experience any interruption as the database underneath scales up and down. And the last thing about Aurora Serverless v2 is that it's going to support all of the features of Aurora. That includes high availability, read replicas, cloning, backtrack, and so on, in a multi-AZ configuration. So Serverless v2 is going into preview, so you should be able to try it in the next few days. And we really are interested in hearing about your experience as we go through the preview and get ready for GAing this product. We really think that most customers don't really want to manage instances and size up resources and so on. So we're really pushing for serverless to be an experience that works for all workloads in production and gives you the performance that you need at the right price. So I'm going to show you a simple graph. This is from a bunch of tests that we ran. We also used it for a demo in a couple of different sessions. The blue line represents order processing, so it's the orders per second. The orange line represents the ACUs that the database adjusts to in order to respond to fluctuation in the demands on the database. And you can see that the orange line can spike along with the blue line. As more demand is put on the database adjusts its resources to enable the workload to run. And then at some point when the workload starts to quiet down, the orange line you can see starts to step down the resources and gets back down to whatever minimum level that you set, or it eventually goes to sleep if your minimum level is set to 0. You can see that this level of scaling will be much better in allowing you to utilize serverless for your workloads and cost optimize for best price performance. Now, we've had global databases for a while. Global databases are great for cross-region read replicas, as well as to meet your disaster recovery needs. So this year, we've enabled up to 6 replicas in the global database configuration. And that gives you 90 read replicas across the entire state, because you can have 16 instances in each of the 6 regions. So that's a lot of read capacity across the globe. So that's one of the improvements that we made this year. Now, we also introduced managed RPO. With managed RPO, you're able to limit the lag in your global database replication. And what this means is you can actually do a setting and say, look, I don't want my replicas across the regions to ever lag more than, 20 seconds. And if they do, stop taking writes. Because maybe you have a financial application that is very strict in ensuring durability across regions. And you're not going to lose more than 10 seconds if something bad happens. So if you set your managed RPO, say to 20 seconds, in this model, we have 3 regions with 1 primary and 2 secondary regions. And we've set the RPO to 20 seconds. And in this model, we see that if Northern Virginia starts to lag because maybe there's a network issue, the system continues because Ireland still has lag of less than 20 seconds. So everything works. But let's say we assume that the lag increases and Ireland starts to fall behind. And in this case, the primary stops taking writes because it says, hey, I'm not safe anymore, so I'm going to stop taking writes. Until one of the regions recovers and the lag closes and the writes resume. Again, this is a model for applications that have very strict RPO requirement. Another feature that we announced earlier was Aurora Global Database with write forwarding. In this model, again, this has been out for a while, so you can go read about it. you can actually write to the read replicas, and the read replicas will forward the writes to the primary, and the primary will replicate them back. This is a really convenient developer feature. So if you have an application, you don't really have to figure out, is this a read endpoint, write endpoint? You just do the writes that you need, and you do the reads, and the database will do the right thing. If you're writing to a read replica, it'll just forward it to the right place, and everything will work. And lastly, we're working on global data's managed failover. And managed failover is coming soon, in a few weeks. And this will allow you to basically do failover between primaries and secondaries without having to rebuild the topology of your cluster. And the way it works is that if you decide to promote Northern Virginia in this picture to the primary instead of Ohio, you just decide to do that. And that causes Ohio to stop taking writes and waits for Virginia to catch up. And then Virginia becomes the primary, and the entire global database topology gets rerouted. So everybody now becomes secondary to Northern Virginia. And then you can do failovers and failbacks. And this allows you to do drills as well as switching roles as necessary in your disaster recovery solutions. Again, this is not out yet, but it'll be out soon. All right, moving on. Let's talk about versions. I'll quickly cover this. So we have automated minor version upgrades for both MySQL and Postgres. We have in-place upgrade for Postgres from 9 to 10, 10 to 11, and 11 to 12. And Postgres 12 will be coming soon, early part of 2021. And for MySQL, we'll be supporting upgrades in place from 5.6 to 5.7. And early next year, we'll be going to preview for Aurora MySQL 8, which we're all very excited about. So hopefully you will all participate in our preview. Now, I want to cover one more topic before we bring this to an end. So we have a new feature coming out for Postgres, and it's called Babelfish for Aurora Postgres. And the idea of Babelfish is to enable Aurora Postgres to take commands and connections from applications that are developed for Microsoft SQL Server. And as you can imagine from the name, Babelfish basically makes Postgres bilingual. It can understand T-SQL, and it can use the SQL Server TDS protocol, wire protocol, to talk to applications. So you have an application that's already been written for SQL Server. Let's say you have an application written in C# and it's using .NET, and it uses the framework capabilities with the SQL client. You can actually point that application to Postgres and to the TDS endpoint of the Postgres database, and it'll work. Now, in some cases, you might have to make adjustments to the application because not all features of SQL Server will be supported initially, but we've optimized for most of the interesting and most of the capabilities that are generally used to build applications. But really cool thing about this is you can continue to use your existing drivers. So if you're using, again, .NET, or you're using ODBC, or using JDBC, because we have wire protocol compatibility, you don't actually have to go and change the app. So if you have an application for SQL Server that you want to port to Postgres, this makes life a lot easier because you can actually run the app without switching drivers, without switching your development environment, without switching your client. And then you might have to make some adjustments to the SQL text. But that's a lot simpler. Now, there's a lot of deep dive sessions on Babelfish, so I encourage you to go and take a look at those sessions for more details. The other thing about Babelfish is that we'll be open sourcing this project. So Babelfish for Postgres, because we believe it'll be useful for general Postgres community. So this is not going to be an Aurora only thing. The project will be open sourced in 2021. And again, we encourage you to participate and help us make it better. If you have some features that you really want, well, you can help us build them. and you don't have to wait for us to build everything for you. Again, we're very excited about Babelfish. And one of the key things about Babelfish is that we're not going to compromise correctness. So when you run your application, it'll either work and it'll work correctly, or you'll get an error. And then we'll have to go and, add the capabilities necessary for whatever is missing. Again, wire protocol compatibility and interoperability, meaning the Postgres database that you connect to with T-SQL, you can also connect to with the normal PostgreSQL clients. So you can create a stored procedure from T-SQL and you can execute it from Postgres. You can create a table from T-SQL. You can go into your favorite, SQL Server Management Studio and create a table, and then you can connect to the database from Postgres side and query the table. So that's a little bit about Babelfish. Obviously, there's a lot more to unpack there, so I encourage you to go and take a look at the sessions. We have some other related session. Obviously, we have one deep dive for Aurora Postgres, DAT 301. We have a deep dive for Aurora MySQL, which is DAT 302. We also have demystifying Aurora storage, which is DAT 401, along with a session for Babelfish and serverless v2. So thank you very much for watching the video, and I hope you enjoyed it and found it useful, and thank you.